Last week we looked at how to display data in a histogram. And so what I have for you today on the screen is a histogram displaying the length of housefly wingspans for 100 flies in millimeters. Notice that the shape of this histogram is bell-shaped and it's symmetric about the middle here at 46. We say that this data is approximately normal. We can draw a normal curve to approximate the shape of the data here. So you can see my curve here in red, which gives us sort of a perfect idea of what the shape of the data is. And we're going to use normal curves this week to give information about data. So we might ask something like this: what proportion of flies have a wingspan greater than 48 millimeters? Well, if you look at the histogram, we're going to count the heights of the bars that represent data greater than 48. So that's these orange bars here, and if I count those heights, I'm at approximately 15, 10, 4, and 2. So I'm going to add those together and then divide by the total number of observations. There were 100 total flies to get 0.31 of the flies have a wingspan greater than 48 millimeters. Now, we said this was approximating a normal curve, so here's my normal curve. And if I look at that normal curve and find the area to the right of 48 on that curve, so that's this shaded orange area, that area is 0.304, which is pretty close to 0.31. So that's a good approximation of what's happening here. Okay, so our goal this week is to look at normal curves. Generally speaking, normal curves are always symmetric. They have a single peak. They're bell-shaped with the highest point of the curve at the mean. The normal curve is completely described by the mean, mu, and the standard deviation, sigma. We're going to use mu to describe the mean and sigma to describe the standard deviation because these numbers are to describe the population, not just the sample. In our normal curve, the mean is equal to the median, so the mean is right in the center of our data, and the total area under the curve is 1. Every normal curve follows a special rule called the 68-95-99.7 rule. And what this rule tells us is it tells us something about how our data is spread about the mean. So a normal curve is completely described by the mean and the standard deviation. So what I've drawn here is a normal curve. Notice it's got a single peak here at the mean, at mu. And if I go out one standard deviation to the left and to the right, that means I'm going to subtract sigma to the left and add sigma to the right. Then the 68-95-99.7 rule says that 68% of the data lies within one standard deviation of the mean. So what that says is 68% of the data, let's skip ahead, is between the mean minus the standard deviation and the mean plus the standard deviation. If I go out 2 standard deviations, that's going to contain 95% of my data. And if I go out 3 standard deviations, that's going to contain almost all of my data. 99.7% of the data is within 3 standard deviations of the mean. And that's true for any normal distribution. So any distribution that's normal with a mean of mu and a standard deviation of sigma.